Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. So express 1 over x minus 1 minus 1 over x plus 1 as a single fraction. Okay, so fractions, for anybody who forgets them, okay, always require a common denominator. Okay, in this case it would be 15. How about I not write it as 15 like I would in algebra, and I'll write it down as 3 by 5. Okay, so still 15. Okay, so what you do is you multiply everything by your common denominator. It doesn't matter whether it goes before or after the term that's there. So there's my, there's my 3 by 5s. There's my 3 by 5, 3 by 5, 3 by 5. So everything is commonized up. Okay, why do we do that? Well, that's to see what cancels. So we end up then with 10 5 2s minus 1 by 3 over 15, which is equal to 7 over 15. Okay, not the way you would have done it in school. What you would have done is put the 15 on the bottom, and you went when 3 goes into 15 5 times, 5 2s minus, and then you would have gone 5 into 15 goes 3 times the number on top. Okay, what I want you to take note of is the fact that when I did it this older way, I got 5 by 2 on top, which is what I get here doing it this way. I get 3 by 1 here, which is what I get here. And on the bottom, I get the 3 by 5. So when you're doing algebra, we don't do it any differently than we do it numerically. Okay, I'm still getting for this one 10 minus 3 over 15, which is 7/15. Okay, I'm still getting the same thing. Your brain might approach it slightly different. So this is typically how it's taught in school, but maybe not by everybody. So why am I telling you all this? Well, I'm trying to show you the steps that's involved in algebraic fractions. So my common denominator is the bottoms multiplied by each other. Now notice I didn't call it the lowest common denominator because it may not be the lowest, but it's definitely common in that 3 will always divide into 3 by 5, and 5 will always divide into 3 by 5, because those two numbers there are part of the denominator. In the same way, if I make my denominator for algebraic fractions be the product of the bottoms, x minus 1 then will always divide into it, and so will x plus 1. Okay, what goes on the top? Well, just like I did it the long way here, I'm going to do it for my algebraic fraction. So I'm going to have x minus 1 by x plus 1 by what was there already. Okay, that minus in the middle is there. Okay, and then put on my common denominator as such. Okay, so all I've done is that's my old equation basically, and I've just multiplied above and below by the same thing. So in effect, just like before, when you multiply above and below by the same thing, you're only multiplying by 1. He cancels with him, he cancels with him, so that you're left with 1 times x plus 1 minus 1 times x minus 1 over x minus 1, x plus 1. Okay, note very important. I haven't dropped the bottom line in this one. If this was a solve, that bottom line wouldn't appear. But this isn't a solve, it's write it as a single fraction. So if you drop the bottom line, you've lost your fraction. So you can't drop the bottom line unless it's a solve, unless it has an equals to in the middle. So 1 by x is x. I'm just getting rid of my brackets now. Well, let's multiply this out. Okay, then does anything cancel? Well, x and minus x cancels, so that you're left with 1 and 1 is 2 over the bottom plus x minus x cancels, and you're left with x squared minus 1. You may have been able to recognize that this was the difference of two squares, so you could go straight from there to there if you can spot that that top bit is the difference of two squares, which is what I was going to write down, but I didn't. So that there is your full answer. That is, express that as a single fraction, 2 over x squared minus 1. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.